What if a river could bleed red like an open wound, glow the color of a cloudless sky, or turn as black as midnight while flowing beside water the color of coffee, the two never mixing? What if the water in front of you was so acidic it could dissolve your boots, or so clear you could count the pebbles 30 feet below the surface? These are not paintings. These are not filters. These are real rivers flowing right now on every continent on Earth, and most people will never know they exist. By the end of this journey, you will understand why color, the simplest thing our eyes perceive, can also be one of nature's deepest mysteries. We begin somewhere gentle, somewhere you could visit next year. But stay with us, because every river from here forward will push the boundary of what water is supposed to look like, until we reach a place so strange that scientists still study it to understand life on other planets. Hues, Costa Rica. Deep inside Tenorio Volcano National Park, a river the color of a swimming pool cuts through dense rainforest, and for decades, local legend claimed that God himself dipped his paintbrush here after painting the sky. The truth, discovered by chemists in 2013, is almost stranger than the myth. Rio Celeste is formed where two ordinary colorless rivers meet, at a point locals call Los Teñideros, the dye makers. One river carries dissolved minerals, the other carries fine particles of aluminosilicate. When they combine, they create tiny mineral particles that scatter blue light through a process called scattering, the same optical trick that can make ocean water appear turquoise. Neither river was ever colored at all. The color exists only in how light bounces off the mixture. Visitors hike through cloud forest and volcanic steam vents to reach it, sharing the trail with tapirs and howler monkeys. The danger here is subtle. Sudden tropical downpours can turn calm trails into flash flood zones within minutes. This is the gentlest introduction to a phenomenon we will see grow far more extreme as we travel deeper into the world's hidden waterways. Verzasca River, Switzerland. In the Swiss canton of Ticino, glacial meltwater has carved a valley where the river glows an impossible shade of emerald blue, so vivid that early travelers assumed the water was dyed for tourism. It is not. The Verzasca River owes its color to finely ground rock particles called glacial flour, produced when moving ice grinds bedrock into powder fine enough to stay suspended in water, scattering sunlight into brilliant blues and greens. The riverbed itself, polished smooth by centuries of flow, is made of pale dolomite rock that reflects light back through the water like a mirror beneath glass. Small villages like Lavertezzo built stone bridges centuries ago that still arch over these pools today, and locals still swim in water barely above freezing even in midsummer. The current, though it looks gentle, has claimed lives among cliff divers who underestimate its hidden depth and force. If a glacier can paint water this brilliantly in the Alps, imagine what happens when an entire river system is carved through limestone canyons instead of granite. That is exactly where we go next. Krka River, Croatia. Cascading through a limestone gorge in Dalmatia, the Krka River tumbles over travertine barriers formed by a living process, not a geological accident. Mosses, algae, and bacteria in the water constantly deposit calcium carbonate, slowly building natural dams called tufa barriers that can grow centimeters every year. This ongoing biological construction gives the river its layered waterfalls and its shifting palette of turquoise, jade, and deep green, changing with mineral concentration and sunlight angle. Beneath the falls, freshwater springs feed the river with exceptionally clean water, supporting otters, eels, and rare orchids along its banks. Medieval watermills once lined these waters, harnessing the current for grain, and ruins of the mills still stand today as quiet monuments to human adaptation. The greatest danger to Krka now is not the water itself, but its popularity. Unmanaged tourist traffic threatens the very microorganisms responsible for the river's famous color. As remarkable as living rock formations are, some rivers achieve their colors through chemistry so rare that only a handful exist on the entire planet. Cetina River, Croatia. While tourists crowd nearby coastal towns, few venture inland to the Cetina River, where jade blue water winds through a canyon so steep it feels carved by something other than nature's patience. The river emerges from a karst spring near the village of Vrlika, its water having spent years filtering through underground limestone caverns before reaching daylight, arriving already crystal clear and mineral-rich. This underground filtration removes sediment almost entirely, while dissolved limestone particles scatter light into deep blues and greens. Local rafting guides know sections of the canyon so narrow that sunlight only touches the water for a few hours each day. Ottoman-era ruins and abandoned watermills sit half-swallowed by vegetation along its banks, evidence of centuries of contested history in this borderland region. Sudden rockfalls and unpredictable spring flooding make certain gorge sections treacherous even for experienced paddlers. If limestone alone can produce water this vivid, what happens when an entire mountain range of similar rock feeds a river system across international borders? The Balkans, it turns out, are hiding several more. Socha River, Slovenia, flowing from the Julian Alps into a valley that witnessed some of the deadliest battles of the First World War. The Socha River carries a color so intensely emerald that Ernest Hemingway, who served here as an ambulance driver, referenced its beauty in his writing about the war. The green comes from a combination of glacial and karst spring water, extremely low sediment levels, and a high concentration of dissolved limestone minerals, which together allow the water to absorb red wavelengths of light while reflecting green and blue back to the eye. Because the river originates from underground springs rather than surface runoff, its color intensifies further downstream as more mineral-rich water joins the flow. Fly fishermen travel from across Europe to catch the endemic marble trout found nowhere else on Earth. Beneath the natural beauty lies a darker history. Unexploded ordnance from a century-old war still occasionally surfaces in the surrounding hills. From a river shaped by human conflict, we travel to one shaped entirely by isolation, hidden deep in a canyon few outsiders have ever entered. Neretva River, Bosnia and Herzegovina. Its water originates from an underground karst spring system, emerging already filtered of nearly all sediment. Its water originates from an underground karst spring system, emerging already filtered of nearly all sediment, then gathering additional clarity as it passes through limestone canyons lined with travertine deposits. The historic Stari Most Bridge in Mostar, rebuilt after being destroyed during the Bosnian War in the 1990s, arches nearly 90 feet above the river. And for centuries, young men have proven their courage by diving from it into the frigid current below, a tradition that continues today as a certified diving competition. Beneath its calm surface, the river hides sudden temperature drops and strong undertows near the bridge pillars. War history still lingers here too. Some sections of the surrounding hillsides remain marked with old minefields from the 1990s conflict, a stark reminder that natural beauty and human tragedy often share the same geography. From a river reborn after war, we move toward a canyon so remote that entire stretches remain unnamed on any map. Tara River, Montenegro, slicing through Europe's deepest canyon, over 4,300 feet at its most dramatic point. The Tara River glows a shade of green so saturated that early Yugoslav-era filmmakers used its gorge as a stand-in for the Grand Canyon of Colorado. The intensity of color comes from an unusually high concentration of dissolved limestone combined with exceptionally low turbidity, since the river is fed largely by underground springs rather than surface erosion. UNESCO designated the canyon a protected biosphere reserve, partly to preserve rare species like the Balkan lynx that still roam its forested slopes. Remote monasteries built centuries ago cling to cliff sides above the water, accessible only by narrow mountain paths, chosen deliberately by monks seeking isolation from the world. Whitewater rapids here are rated among the most technically demanding in Europe, and several rafting fatalities over the decades serve as sober reminders of the canyon's power. If canyons like this exist hidden across the Balkans, imagine what remains undiscovered along Europe's less traveled coastlines, where an even more obscure river waits. Zrmanja River, Croatia. Almost unknown outside Croatia itself, the Zermanja River flows through a canyon so narrow in places that direct sunlight barely reaches the water, yet it still glows a brilliant turquoise that seems to generate its own light. Like its more famous Croatian cousins, its color originates from karst spring water rich in calcium carbonate, filtered through limestone for years before reaching the surface completely free of the sediment that dulls most rivers. Ancient Illyrian and Roman ruins dot the surrounding hills, evidence that humans have valued this valley for over 2,000 years. Yet modern tourism has barely touched it. Local shepherds still use centuries-old paths along the canyon rim to move livestock between seasonal pastures. Flash floods here arrive with almost no warning, since rainfall in the surrounding karst plateau can travel underground for miles before erupting suddenly into the canyon below. We now leave Europe's hidden limestone rivers behind and travel across the Atlantic to a country where the water is not colored by minerals at all, but filtered by an entire underground world of caves. Rio Sucuri and Rio da Prata, Bonito, Brazil. In the Brazilian region of Bonito, meaning beautiful in Portuguese, rivers like the Sucuri and Prata run so transparently blue that snorkelers describe the sensation of floating through air rather than water. This extraordinary clarity comes from limestone bedrock beneath the entire region, which filters the groundwater feeding these rivers so thoroughly that sediment is almost completely removed before the water ever reaches the surface. Local guides restrict visitor numbers strictly, requiring snorkelers to enter single file and avoid touching the riverbed, since even light kicks of sand can cloud the water for hours. Dorado fish, some over a meter long, swim calmly beside human visitors, undisturbed by decades of controlled ecotourism that has made this one of the most successful freshwater conservation stories on Earth. Indigenous Guado communities have lived along these waterways for generations, relying on the river's health as a measure of the forest's own well-being. The greatest threat is invisible. Any upstream deforestation or agricultural runoff could destroy the fragile clarity within a single rainy season. From water so clear it disappears, we now travel to a river so yellow it changed the course of an entire civilization. Known to the Chinese people as Huanghe, the Yellow River carries a color so distinctive that it gave China one of its earliest names, and so much sediment that it has been called both the cradle of Chinese civilization and China's sorrow. The river's yellow-brown color comes from massive quantities of loess, a fine wind-deposited soil that blankets the Loess Plateau in northern China, easily eroded into the water as the river cuts through the region. At its most extreme, the Yellow River can carry enough suspended sediment to make the water nearly 40% solid material by weight during flood season, among the highest sediment loads of any river on Earth. This same sediment has caused the riverbed to rise higher than the surrounding farmland in places, requiring massive artificial levees that, when breached throughout history, have caused some of the deadliest floods ever recorded. Ancient dynasties rose and fell based on their ability to manage these floods. And modern China still invests enormous resources into controlling the river's unpredictable temperament. From a river colored by an entire continent's soil, we now cross into Africa, where two rivers share a name based on color, yet could not look more different from one another. Rising from Lake Tana in the Ethiopian highlands, the Blue Nile earns its name not from a vivid dye, but from relative clarity and dark reflection. Compared to its sediment-heavy sibling, the White Nile, a naming convention established by early Arab and European travelers who distinguished the two branches by color long before modern hydrology existed. The river plunges over the Tisisat Falls, meaning smoking water in Amharic, where mist rises so thickly from the crashing water that it can be seen from miles away. And Ethiopian Orthodox tradition considers the site spiritually significant, tied to centuries-old religious ceremonies still held nearby. Despite carrying less visible sediment than the White Nile, the Blue Nile actually contributes the majority of water and fertile silt to the combined Nile system downstream in Sudan and Egypt, making it historically vital to Egyptian agriculture for thousands of years. Steep gorges along its course remain some of the least accessible terrain in the Horn of Africa, complicating both exploration and modern dam construction projects. Political tensions between Ethiopia, Sudan, and Egypt over control of this water continue today, proving that a river's color can matter less than the power it holds over nations. Just south, another Nile carries an entirely different story within its pale waters. Originating from Lake Victoria, the White Nile takes its name from the pale, whitish-gray clay sediment suspended in its waters. A stark contrast to the darker Blue Nile, it eventually joins near Khartoum, Sudan, in a visible meeting point where the two colored currents run side by side before slowly merging. This sediment originates largely from the swamps and wetlands of South Sudan, particularly the vast Sud wetland, one of the largest freshwater swamps on Earth, where the river slows dramatically and deposits enormous quantities of fine clay and organic material. 19th century European explorers, including John Hanning Speke, spent years and considerable suffering attempting to locate this river's true source, a mystery that captivated geographical societies for decades before being confirmed at Lake Victoria. Nile perch, some growing over 6 feet long, thrive in these murky waters, supporting fishing communities who have relied on this river for millennia. Civil conflict in South Sudan has made significant stretches of the White Nile dangerous or inaccessible to outsiders for years at a time, hiding much of its ecosystem from modern scientific study. From two rivers defined by contrasting shades of a single color, we now travel to a river whose color changed completely because of a single piece of human engineering. The Colorado River earned its Spanish name, meaning colored red, from the reddish-brown sediment it once carried from the canyon lands of the American Southwest, a color so consistent that early Spanish explorers described it centuries before modern geology explained why. That sediment, primarily eroded sandstone and shale, gave the river its historic rust-red appearance as it carved the Grand Canyon over millions of years. Everything changed in 1963 when the completion of Glen Canyon Dam created Lake Powell and began trapping the vast majority of sediment before it could reach the river downstream, transforming the water into a cold, clear blue-green color that Grand Canyon visitors see today, a shade the river had never naturally displayed in that stretch before. This engineering-driven color change remains one of the most dramatic examples on Earth of humans accidentally altering a natural landmark's appearance. Native American communities, including the Havasupai and Navajo, whose ancestral lands border the canyon, have documented the river's shifting character for generations. And today, periodic controlled floods are released from the dam specifically to redistribute remaining sediment and restore fragile canyon ecosystems. Severe drought and rising water demand across 7 states now threaten to reduce the river's flow to historic lows, raising real questions about its future. If one dam can silence an entire river's natural color, imagine what a hidden mountain range can create when left completely undisturbed. Flowing through a limestone canyon so remote that Montana issues only a few dozen permits per day to float it, the Smith River glows a vivid emerald green found almost nowhere else in the American West. This color results from a combination of glacially influenced tributaries and limestone bedrock, which together keep sediment levels remarkably low while dissolved minerals scatter light into deep saturated greens. Access is so restricted that permits are awarded through an annual lottery system, and floaters must be entirely self-sufficient for up to 5 days, carrying all food, water, and waste out with them since no services exist along the 60-mile stretch. Blackfeet and other indigenous nations historically used this valley as a seasonal hunting ground, and pictograph sites along the canyon walls still bear evidence of that presence today. Modern mining proposals near the river's headwaters have sparked significant conservation battles, as many fear that heavy metal runoff could permanently destroy the very clarity that makes the canyon famous. Sudden afternoon thunderstorms in this exposed canyon can trigger dangerous flash flooding with almost no warning for stranded floaters. From an emerald canyon guarded by permits and lottery numbers, we travel to a river colored not by minerals dissolved in water, but by an entire glacier grinding rock into powder above it. Deep within Washington's Olympic rainforest, the Hoh River runs a striking milky turquoise. Fed directly by the Hoh Glacier high on Mount Olympus, one of the last glaciers in the contiguous United States still actively carving fresh rock. As the glacier grinds against bedrock, it produces extremely fine rock powder called glacial flour, so light that it remains suspended in the meltwater rather than settling, scattering sunlight into pale blue and green hues visible for miles downstream. This same rainforest receives over 12 feet of rainfall annually, creating one of the only temperate rainforests in North America, where massive Sitka spruce and hemlock trees draped in moss line the riverbanks. Roosevelt elk herds, some of the largest in the country, graze along the valley floor, drawing wildlife photographers from around the world. Because the Hoh Glacier continues retreating due to rising temperatures, scientists warn that this milky color and the river's cold temperature, critical for salmon spawning, may both change permanently within decades. If glaciers can paint rivers this vividly in temperate rainforests, imagine what happens across an entire subarctic wilderness fed by dozens of glaciers at once. Originating from the Columbia ice field, one of the largest accumulations of ice in the Canadian Rockies, the Athabasca River carries a pale, milky blue color for hundreds of miles as it flows north toward Lake Athabasca. Glacial flour produced by the grinding ice above gives the water its opaque, almost paint-like appearance, a color that intensifies during summer months when warmer temperatures accelerate glacial melt and sediment production. Indigenous Cree and Dean peoples have traveled and fished along this river for thousands of years, naming it for the grass and reed beds found along its lower reaches. The river's watershed today faces significant environmental scrutiny due to nearby oil sands development, one of the largest industrial projects on Earth, raising ongoing concerns about downstream water quality for communities who depend on the river. Sudden ice jams during spring thaw can cause dramatic and dangerous flooding events along the river's course, sometimes forcing entire communities to evacuate with little warning. From a glacier-fed giant in North America, we now travel to the opposite side of the Pacific, where an unstable glacier creates a river so unpredictable that entire towns have had to relocate. Fed directly by the rapidly retreating Franz Josef Glacier, the Waiho River runs a pale, milky gray-blue, carrying enormous volumes of finely ground rock flour down from the southern Alps. Unlike more stable glacial rivers, the Waiho has become dangerously unpredictable in recent decades as the riverbed has risen so significantly from accumulated sediment that it now sits higher than parts of the surrounding town, forcing the relocation of homes and infrastructure away from its banks entirely. Local Maori tradition holds deep spiritual significance for the glacier itself, known as Karoimata o Hine Hukatere, the tears of a legendary figure who lost her lover to the mountain, a story still told to visitors today, alongside the scientific explanation of glacial retreat. Rapid climate-driven glacial melt has accelerated the river's instability, with stop banks requiring constant reinforcement to prevent catastrophic flooding of nearby roads and buildings. Guides who once led glacier walks directly onto the ice have had to abandon routes entirely as the glacier retreats further up the valley each year. If a single retreating glacier can reshape an entire town's geography, imagine what a valley shaped by ancient limestone deposits and living algae can produce in terms of color alone. Winding through a UNESCO World Heritage Valley in the mountains of Sichuan Province, the interconnected streams and pools of Jiuzhaigu display an extraordinary range of colors within a single flowing system. from deep sapphire blue to jade green to golden yellow, sometimes shifting dramatically within a few dozen meters of water. This effect results from a combination of exceptionally high calcium carbonate concentration, which creates travertine formations similar to those in Croatia, along with submerged vegetation, algae, and mineral deposits that each reflect light differently depending on depth and season. Local Tibetan and Chiang communities, who have lived in this valley for centuries, developed legends describing the pools as fragments of a broken mirror once used by a goddess, a story now shared alongside the scientific explanation for tourists. A devastating earthquake in 2017 altered portions of the valley's waterways, temporarily draining some pools while creating new ones, demonstrating how fragile and geologically active this landscape truly is. Strict visitor limits and boardwalk-only access now protect the delicate mineral balance responsible for the colors, since even minor pollution can disrupt the chemistry within these shallow pools. From a valley of shifting rainbow water shaped by gentle mineral deposits, we now travel to a river so aggressively colored by chemistry that NASA scientists use it to study conditions on Mars. Flowing through Spain's Andalusia region, Rio Tinto runs a deep, unsettling blood red for nearly 50 miles. A color caused not by pollution, but by over 5,000 years of natural and human mining activity, exposing massive iron and copper sulfide deposits to air and water. Extremophile bacteria and archaea, organisms that thrive in highly acidic, metal-rich environments most life cannot survive, oxidize the iron in the water, producing rust-colored iron oxide compounds that stain the entire river a striking crimson. The water's pH regularly measures below 2.5, roughly comparable to vinegar, making it one of the most acidic natural rivers on Earth. Yet, remarkably, this hostile chemistry supports a surprisingly diverse community of specialized microorganisms found almost nowhere else. NASA and European Space Agency scientists have studied Rio Tinto extensively since the early 2000s, using it as a real-world analog for the ancient river channels and mineral deposits identified on Mars, since the chemistry here may resemble what early Martian water once looked like. Roman and Phoenician miners extracted copper and silver from this region over 2,000 years ago, and the surrounding hills remain scarred with abandoned mining infrastructure spanning multiple civilizations. Direct skin contact with the water can cause irritation, and drinking it is lethal, making Rio Tinto beautiful only from a careful distance. From a river turned red by ancient minerals, we now travel into the heart of the Amazon, where an entirely different chemical process turns water as black as ink. Stretching for over 1,000 miles through the Amazon rainforest, Rio Negro, meaning Black River in Portuguese, carries water so dark it appears almost like tea or strong coffee under direct sunlight. A color caused by tannins and other organic compounds released as decomposing leaves and vegetation steep in slow-moving, nutrient-poor water. Unlike the sediment-rich Amazon mainstem, Rio Negro flows through sandy, nutrient-depleted soil that produces very little suspended sediment, allowing these dissolved organic tannins to dominate the water's appearance completely. This tannin-rich water is naturally more acidic and significantly lower in dissolved minerals than typical river water, creating unique conditions that support species found nowhere else, including specialized fish adapted to this dark, low-oxygen environment. Indigenous communities along Rio Negro have relied on its relatively mosquito-reduced waters for centuries, since the tannins and acidity make it less hospitable to mosquito larvae than surrounding rivers, an unexpected benefit of its unusual chemistry. Because the water absorbs light so effectively, visibility below the surface can drop to mere inches, hiding an entire ecosystem from view just below the black surface. From a river darkened by an entire rainforest's decay, we travel to a lesser-known Blackwater River hidden near one of the tallest waterfalls on the planet. flowing from the remote tabletop mountains of Venezuela's Canaima National Park, home to Angel Falls, the world's tallest uninterrupted waterfall. The Caroni River carries the same deep tea-black color found in Rio Negro, produced by tannins leaching from the ancient sandstone plateaus and dense vegetation surrounding its source. These tepui, isolated flat-topped mountains rising sharply from the surrounding jungle, are among the oldest geological formations on Earth, some dating back nearly 2 billion years, and their extreme isolation has allowed unique plant and animal species to evolve completely separate from surrounding ecosystems. Indigenous Pemon communities consider these tepui sacred, believing they are home to powerful spirits, a belief woven throughout regional folklore for centuries and still respected by modern visitors and guides. Reaching the Caroni's upper reaches requires small aircraft, multi-day canoe travel, or difficult overland trekking through terrain with almost no infrastructure, keeping this region among the least visited in South America despite its extraordinary scenery. Political instability and economic crisis within Venezuela have made travel logistics increasingly difficult and unpredictable in recent years, adding real-world risk on top of the region's natural remoteness. From one hidden Blackwater River beneath ancient mountains, we now travel to a river so remote and so seasonal that most of humanity will never see its full color at all. Deep within Colombia's Serranía de la Macarena National Park, a river locals call the Liquid Rainbow transforms briefly each year into one of the most visually complex waterways on Earth, displaying red, yellow, green, blue, and black simultaneously within the same current. This extraordinary display comes almost entirely from a single aquatic plant, Macarenia clavigera, an endemic species that grows attached to rocks along the riverbed and turns a vivid red during a narrow window between wet and dry seasons, when water levels and sunlight are precisely balanced. Outside this brief seasonal window, typically only a few months between roughly June and November, the plant remains green, or the river runs too high and turbulent to reveal any color at all, meaning most visitors who arrive at the wrong time see only an ordinary jungle river. For decades, this region remained completely inaccessible to tourists due to armed conflict between Colombian guerrilla groups and government forces, only opening cautiously to limited visitor numbers after peace negotiations reduced fighting in the surrounding countryside. Strict environmental regulations now prohibit sunscreen, insect repellent, and even shoes with heavy tread within the river itself, since minimal chemical contamination can damage the delicate plant colonies responsible for the phenomenon. Local guides, many former residents of once conflict-affected communities, now find sustainable income protecting the very river that geography and history once hid from the world. If a single plant can paint a river 5 colors at once, what could possibly follow such a display? The answer lies at the bottom of the planet, where color emerges not from life, but from something ancient and forgotten beneath the ice. At the edge of the Taylor Glacier in Antarctica's McMurdo Dry Valleys, a startling crimson outflow stains the white ice, a phenomenon so visually shocking that early 20th century explorers who first encountered it assumed it was caused by red algae before modern science revealed a stranger explanation. Blood Falls is fed by an ancient reservoir of extremely salty water trapped beneath the glacier for possibly over 1 million years, sealed away from oxygen and sunlight in near total isolation, creating one of the most extreme and unusual ecosystems ever discovered on Earth. When this brine finally reaches the surface and contacts oxygen, dissolved iron within it rapidly rusts, turning the outflow a deep red almost instantly upon exposure to air. Remarkably, scientists in the 2000s discovered an entire community of microorganisms living within this sealed, oxygen-free, iron-rich brine, surviving through unique chemical processes rather than photosynthesis, findings that have since informed research into how life might exist in similarly extreme environments elsewhere in the solar system, including beneath the icy surfaces of Jupiter's moon Europa. Reaching Bloodfalls requires specialized cold weather expedition support, extreme logistical planning, and tolerance for temperatures that regularly fall below -20 degrees Fahrenheit, placing it among the most physically inaccessible colored waters on the planet. Almost no other place on Earth demonstrates so clearly that color in nature can emerge from complete darkness and isolation rather than sunlight and life. From the coldest, most sealed-away water on the planet, we now travel to one of the most violently acidic rivers ever measured, born from an active volcano's furious chemistry. Flowing from the crater of Kawa-Ijen, an active volcano famous for its otherworldly blue flames caused by burning sulfuric gas, the Banyu Pahit River, whose name literally translates to bitter water, carries a strange, milky turquoise color born from some of the most extreme natural chemistry found anywhere on the planet. The crater lake feeding this river is considered the largest highly acidic volcanic lake on Earth, with pH levels measured as low as 0.5, acidic enough to dissolve metal and severely burn human skin on contact, while sulfuric compounds within the water simultaneously scatter light into an eerie pale blue-green hue. Local sulfur miners, working with minimal protective equipment, descend into the crater daily to hand-carve chunks of raw sulfur weighing up to 90 pounds each, carrying them up steep volcanic slopes for meager wages, one of the most physically punishing and dangerous occupations still practiced anywhere in the world. Toxic sulfur dioxide gas regularly rises from the crater in dense clouds capable of causing severe respiratory damage within minutes, and periodic phreatic eruptions, sudden explosive releases of steam and gas, have injured and killed visitors and miners without warning in past decades. Downstream, the acidity gradually dilutes as the river merges with other waterways, yet agricultural communities still monitor its chemistry closely since sudden volcanic activity upstream can alter water safety within hours. Few rivers on Earth combine such visual strangeness with such immediate physical danger, and fewer still remain actively inhabited and worked by human hands despite the risk. We have traveled from gentle turquoise pools to a river that can dissolve steel, and now we arrive at the final destination, one that does not just display a single impossible color, but proves that two colors can exist side by side, refusing to become one. Just outside Manaus, deep in the heart of the Brazilian Amazon, the dark tannin-black waters of the Rio Negro meet the pale, sediment-rich, café au lait waters of the Rio Solimões, and instead of blending together immediately, the two rivers flow side by side for nearly 4 miles, their distinct colors clearly visible along a sharp dividing line that boat passengers can reach out and touch with one hand in each river simultaneously. This remarkable resistance to mixing occurs because the two rivers differ dramatically in temperature, density, speed, and acidity. The Rio Negro flows slower, warmer, and more acidic due to its tannin content, while the Rio Solimões, fed by sediment-rich Andean runoff, moves faster, cooler, and denser, and these physical differences prevent immediate turbulent blending even after the rivers technically join into a single channel. Scientists have used specialized equipment to trace this gradual mixing process for miles downstream, finding that complete blending sometimes does not occur until many kilometers past the visible meeting point, an unusually slow process for two rivers of this size. Local guides who have worked these waters for generations can predict almost to the day when seasonal water levels will make the color divide most dramatic, since rainfall patterns across two entirely different river basins, one Andean and one Amazonian, rarely peak in perfect unison. Indigenous riverside communities have navigated and fished this exact confluence for countless generations, treating the boundary not as a curiosity, but as a lived everyday feature of their home. Together, the Solimois and the Negro form the mighty Amazon River itself, meaning that the world's largest river by volume begins, quite literally, as two colors refusing to surrender their identity to one another. It is a fitting final image for everything we have witnessed. Every river in this journey, from a turquoise pool in Costa Rica to an acidic volcanic crater in Indonesia to sealed Antarctic brine older than human civilization, proves the same quiet truth. Water is never simply water. It carries the memory of the rock it dissolved, the life that decayed within it, the glacier that ground it into powder, and the depth of isolation it endured before ever reaching human eyes. These rivers remind us that our planet is still capable of surprising the people who study it most closely, and that true wonder often survives only because a place remained too remote, too dangerous, or too fragile for the world to spoil it. If this journey through Earth's most impossible waters left you seeing rivers differently, consider leaving a like, subscribing for more expeditions to the planet's hidden extremes, and joining us next time as we uncover more places that prove our world is stranger and more beautiful than most of us will ever get the chance to see.